So here is a similar case that I have set up to play with the finite element analysis. And first thing what you need to do is to make your model smaller, so 1/4 of the model. So this case is symmetrical about this plane and also about this plane. So if you will only analyze a quarter of this assembly, then your simulation will be 1/4 in time and in capacity and in number of elements, and with the same number of elements you can get the greater accuracy. So I have made an extrusion to cut away the portion of this 3/4 of this assembly. Also I have decreased it even more because this top part of the roller is not really important for the analysis, and it can be removed if you are only interested in the Hertz here in the bottom. So I also cut it in half. What I also did is I have split the surface of the rail in the proximity of the connection of the tangent point, and I did the same with the roller. So close to the touch to the tangent point, I have a area here, and the same on the rail. I will use it to use local mesh refinement, because with the global mesh settings I was not able to get elements small enough to follow the contact surface that is tiny in this case. So when we go to environment stress analysis, I have set up and I have calculated the analysis because it takes a while. So first of all you apply the frictionless, maybe I will do it like that. So first of all you apply the frictionless constraints to the mirror, to the symmetry planes. So this and this, and you also apply fixed constraint to the bottom of the rail, so on this surface here. This set of constraints properly set up the boundary conditions for this analysis. I have applied 1/4. I have applied y is 0. I have applied the force here. So it is what is the force that you wanted? I believe it was 136 kilonewton by 4. Yeah, but this force is here, so edit. Why I cannot edit this force? So basically this force was here, was applied. Now I am obviously having some problems with selecting it for some reason. But I will check update automatic contacts. For some reason this force is not selectable now. I'm not sure why. So generally I use a separation contact, and this contact is found automatically, and it involves these two surfaces. Also in the analysis properties I have set up very small tolerance for the contact patching to avoid having to have the contact between those two elements beyond the actual contact that will come from the deformation. As for the mesh, as I have said, I have applied 1.1 gravity factor, turn angle. I have created curved mesh elements. I have decreased these values to have pretty small elements. Also, I have defined local mesh refinement, because even with those small values here, the elements still were too big to follow the contact. So in the area here I have defined something is wrong. I've had everything here, so I have 0.2 and I have it here. Yeah, it has already been applied, so I cannot edit it. So it was 0.02 millimeters. So I shall see what the mesh is. But as I wrote in my post, there are no errors now, because previously I had an errors here. So generally, so this is pretty annoying. So as you can see here, the elements generated by the global mesh settings are quite big, and in the area of the contact zone I have much smaller elements that will allow to have the more precise solution in this, close to this point. And what else I see? Well, I cannot delete it, I cannot do anything with that, I'm not sure why. So I tried to run the simulation, and then I will come back to the video, because obviously the results are gone now. So I have to pause the video now, and if I would be able to do it. How do I pause it? Pause. So the analysis has calculated, and we have the results here. As we can see, the tiny elements have been made even more tiny by the adaptive mesh refinement that I have turned on for this simulation. So I have put a quite strict stop criteria and significant number for refinements, and displacement as a condition. Well, I will not go into that. So as we can see here, the mesh is very dense in the area that the contact is present for these two parts, and it is coarse where the results are not interesting. If I turn off the mesh, of course you can now explore the results here. I will only just briefly go through that. We'll turn this off, and if we look from the above, you can clearly see the eclipse that should be there. Only thing is that, as you can see here, the area of the stress, the contact stress, really exceeds the part of the surface that I have pre-selected for the contact area to apply the smaller mesh. So as we can see here, probably, yeah, so here we lose the accuracy of the solution, so probably it would be necessary to redefine the contact area, so the local mesh refinement would take more appropriate shape, so be more in this direction and less here. In any case, we have seen the results, and we have the displacement also very nicely shaped. And if we turn on the wheel again, we can see here that the displacement is continuous, and that the contact between those parts spreads somewhere up to here. So somewhere up to here. So we can clearly see that these elements allowed Inventor to follow the the increasing area of the contact between those two parts. In case of the bigger elements, this would not be so easy, because it would be much harder to get the result, and the result would not be satisfactory for, I think, what we want. If we animate this displacement, something like, I don't know, 30 steps, we can observe how the contact develops, and in the area of the contact increases, because in the beginning only one point of the parts is in contact as the tangent point, and then while load is applied, the deformation increases and the contact area increases using the separation contact, which bonds these surfaces together. This is tricky. This does not always work well, so you have to. So the key is to have elements that are small enough so Inventor will catch interference, and also you should, if you want to follow the contact, you need to minimize the patching, surface patching tolerance, so it would not catch up here, so the contact is there. So I will upload this, and you can download the full simulation from this is Inventor 2017. I'm not sure if you have it, but in any case you can install the trial and use it. So enjoy.